dad is an old school Brooklyn Dodger fan from the 1950s and 60s. Sat down with him for 2 hours watching the game and recording things and asking questions and stuff like that. It was the coolest thing in the world. I'm hopefully going to edit that together and have something for Math of Sports by Wednesday. Oh, it should be great. One of the things that I learned, anybody a Philly fan of anything? Philadelphia? No? I said, Dad, did you ever see a fight on the field or in the stadium? And he's just like, yeah. There were mostly fights in the stands between the Dodger fans and the Philly fans. I'm like, really? Just the Philly fans? He's like, yeah, just always like the Philly fans. And I'm like, how do you figure? And he's like, well, listen. So we'd go to Ebbets Field. We'd go watch a game. And then what would happen? A couple of giant buses would show up with several hundred Philly fans already drunk. And they would come in and they would be starting up fights with the Dodger fans. We always hated it when we played the Phillies because we knew those fans would be driving up from Philadelphia. I don't know. It's just one of those things because he's just like, now the Philly fans, they're the ones in the 70s and 80s at the Eagles games throwing rocks at Santa Claus. You know, that actually happened. There's like a Christmas game and like they had a Santa Claus and they like pelted him. Oh my God. I know. Philly fans are the worst. Just saying. So I had to chide Liston about it because he's a Philly fan of everything. So I don't know. Let's talk about Dolphins. Oh, as a side note, before we talk about Dolphins, I keep going on a lot of things. I am going to have a couple of assignments for you in Google Classroom this week. Pay attention to that. Obviously, you just had the minor on quizzes. I'm going to do a couple things this week. One of them being an opportunity to replace a previous minor assessment grade. Please make sure you're staying on top of that. There's a lot of things that I would like to get done before this week is over because I do not want to leave it for the week that we get back in November because that's the last week of the marking period. I would rather take care of things this week. That would be great. Let's talk about Dolphins. Now, at some point, not yet. At some point, I am going to ask for your notebooks. At some point, I am going to ask for the Chromebooks as well, but we'll get there. Talk about Dolphins. So there were these 30 people, and these 30 people volunteered to be a part of an experiment. And they were evaluated by a psychologist, as we've discussed, in regards to their mental health. Because these 30 people suffered from some form of depression, maybe not severe depression, but some kind of depression that was a little bit more than the average person. So then these 30 people were randomly split into two groups, 15 and 15. And they would all go on this like Caribbean vacation, but 15 of them went on this Caribbean vacation, and they were scheduled to go swim with the dolphins as part of their vacation. And the other 15 were just on the vacation. Now, obviously, it's a Caribbean vacation. It's fantastic. It's wonderful. It's nice. It's all these things in between. But then something miraculous happened when they came back. When they came back, all 30 people were evaluated by the same psychologist to determine whether or not their mental health improved. And here's what happened. So there are people who swam with the dolphins. There are people who did not swim with the dolphins. There's a certain number of people who improved. I should say no improve. And no improve, whatever, I don't care. No improve. Now, we're going to write this down later, so don't worry about it right now. Just focus on what we have up here. So there were 30 people in total, but 15 of them swam with the dolphins. Of the 15 that swam with the dolphins, 10 of them, their mental health improved. I don't know, that's cool. But of the 15 who did not swim with the dolphins, only 3 of them improved. Now, I just want you to consider this for a moment. Consider the ramifications as to what you're seeing up here. At first glance, it appears as if swimming with the dolphins can definitely improve your mental health. But I don't see people flocking to go swimming with the dolphins all the time, or psychologists recommending it, writing you a prescription, here, go swim with a dolphin, you'll feel better. That's not what they're saying, but let's just see what happens here. My question then comes down to the simple question of, or the simple idea, does swimming with the dolphins, or what they call dolphin therapy, does it work? Does it work? There's a lot of thoughts that go into that question. Does dolphin therapy work? Here are 30 people who just participated in an experiment. Is it fair to say, out of those 30 people, the people who swim with the dolphins definitely improve more on average? It's fair to say that out of the 30. But now the bigger question, does it actually work? Will this work again for a different group of 30 people or a different group of 30 people? I don't know. We don't have the money for that or the time. The real big question is, are these results proof that dolphin therapy works? Or are they the result of random chance? This is a really bigger question. Are they the result of random chance? Because if it's the result of random chance, then this kind of discredits dolphin therapy. Let me give you an example. Let's say I have a coin, a penny. Doesn't matter what it is. It's a coin. It has heads, it has tails. I flip this coin 30 times. How many times would you expect the coin to land up tails? 15. You would expect that. Now, if by some chance, by some random chance, I didn't get 15 tails, let's say I got 17 tails, would you say that there's something wrong with the coin? Or would you say, no, that could happen? What do you think? It could happen, right? Yeah. 30 times, 17, yeah, of course, that could happen. That's just random chance. That totally could happen. So now we got to do a little bit of a deep dive into this dolphin therapy thing. Like, is this the result of random chance? Now, if I flip the coin 30 times and I got 25 tails, you might be a little more skeptical. But it could happen. It could happen. It's just unlikely to happen. If I flip that coin 30 times and got 30 tails, you'd be like, wait a minute, maybe there's something wrong with the coin. But it could happen. It could. It's just very unlikely to happen. Now, if it's unlikely to happen, then maybe we have evidence to show that the coin is rigged. If this is unlikely to happen, perhaps we have evidence to show that dolphin therapy doesn't actually work. I don't know. Always be skeptical. Always be skeptical. I showed you part of that John Oliver video. Do you remember that? Right? Where in the beginning, a new study shows blah, 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 blah. What my favorite one? Smelling your own farts can cure cancer. What? No, but this is what they come out with. So, hey, a new study shows swimming with dolphins can definitely improve your mental health. And here's the evidence behind it. I don't know about that. See, what we're going to do today is a couple things. Number one, we are going to randomly simulate dolphin therapy to see if we can replicate these results. We're going to see if we can replicate these results. And after we get our results, we are going to actually put those results into a graphical display to kind of see like, oh, that's what that thing kind of looks like. And then we can determine, whether or not dolphin therapy actually works, or is this the result of random chance? How many total people improved overall out of the 30? How many total people improved overall? 13. 13 people improved overall out of the 30. Would they have improved no matter what? I mean, they're all going on a Caribbean vacation. They clearly are. But why did not as many people improve without dolphin therapy? I don't know. Maybe they were sad they didn't get to swim with the dolphins. I don't know. They're still on a Caribbean vacation. The guy who's asking them the questions about their mental health is not just going to be like focusing on dolphin questions. Are you sad that you didn't get to swim with the dolphins? Yes, I'm sad. Mental health is bad. No, that's not how that works. So let's assume, because we're allowed to do that in statistics, let's assume for just a moment that 13 out of 30 would have improved no matter what. And now, what we are going to attempt to do is we are going to attempt to replicate these results using a random simulation, and we're going to get a final number. So what I'm going to need from you, I'm going to need two things. I'm going to need those notebooks out and open. I'm going to need those Chromebooks out and open because we are going to have to use those graphing calculators. Let me get set up. Swimming with the dolphins. Dolphins are killing machines.
I want to swim with dolphins, but...
You ever see their teeth?
Oh, yeah.
It's like seeing the teeth of a goose. You ever see the teeth of a goose? You know? Hold on one second. Hold on. You're going to hate this. Let's see here. So first of all, dolphin teeth. Right? Look at that.
They're just smiling.
Okay.
They'll never bite you.
They're so nice.
Fine. Here's goose teeth.
Wait, where? I don't see
What?
it. Oh.
See that dolphin?
He looks crazy. He looks mentally insane.
Anyway. Oh, dolphins. All right. Pull this back. Pull this back. Move this over. There we go. Get some paper. Got my pen. Here we go. So now, like I said, eventually this is going to turn into a graphical display. This is going to turn into a graphical display, but let's just call this dolphin therapy. Kind of introducing what we're doing a little bit later. Today is the 26th. We're chugging right along. And I gave you the backstory for dolphin therapy, so I'm not going to go into the details of the backstory. Instead, I am going to recreate the chart that we just had on the board so that you can have it written down. 10, 5, 3, and 12. These were people who improved. These are people who did not improve. These are the people who swam with the dolphins. These are the people who did not swim with the dolphins. Excellent. Now, some people might want to swim with dolphins. You know, they might have this inherent idea of like, oh, I want to swim with the dolphins. Yeah, I really, really do. Okay, but like, I don't know. Maybe if they didn't, maybe they definitely would improve. But that's why there's a random assignment. You have 30 people who have mental health issues, and you randomly split them into these two groups. Either you swam with the dolphins or you did not swim with the dolphins. And by randomly splitting them, you are reducing that type of bias where maybe they did want to swim with dolphins. Well, you're reducing that because if you randomly place them, then maybe 2 or 3 people who wanted to swim with the dolphins, they're split evenly, or they attempt to split them as evenly as possible. Just for the sake of argument, this is called a two-way table. This is called a two-way table. I'm going to put that over to the side over here. This is called a two-way table, or it's also known as a contingency table. It's also known as a contingency table. It's 2 ways of displaying data. You have whether their mental health improved on the left. You have the type of therapy that they got along the top. It's a 2-way table because it's 2 pieces of information at the same time. The big question of the day: does dolphin therapy work Question mark. Or is it the result of random chance? It's two ways to look at the problem. Does it actually work, or is it the result of random chance? Your job is to be skeptical. Your job is to be skeptical. You are to start this whole process by assuming, well, perhaps it is the result of random chance. Now let's see if we can prove it wrong. Perhaps it is the result of random chance. Let's assume for a moment, and this is what statisticians have to do. Let's assume for a moment that dolphin therapy does not work. Let's just assume that there's nothing going on with it. Let's assume that it doesn't matter if you swim with the dolphins or not. Your mental health is just going to do whatever your mental health does after a Caribbean vacation. If we assume that, then we have to assume that those 13 people who improved were going to improve no matter what. We have to assume that those 13 people were going to improve no matter what, regardless of whether they swam with the dolphins or not. And if we assume that, now we are ready to see if dolphin therapy is actually legit. So let me write a couple things down here. Assume 13 out of 30 would have improved no matter what. Assume that 13 out of 30 would have improved no matter what, parentheses, regardless of dolphins. I'm just saying for myself personally, I don't care if I swam with dolphins or not. Again, they're killing machines. People are like, oh no, dolphins are so cute. I'm sorry. No, thank you. I don't know. You know what's weird about dolphins? They're mammals, right? They're mammals, like whales. Why are they still swimming in the ocean? They were so smart. Come on. If they were so smart. Anyway. So now what we're going to do is this. We are going to randomly simulate dolphin therapy. Are going to randomly simulate dolphin therapy. The way that's going to work is this. We are going to let 1 to 13 represent improving. I'm going to write the word improve. And we are going to let 14 to 30 be no improvement. I'm going to show you how I'm going to do this on the graphing calculator, and then you guys are going to do the same thing on your graphing calculators. Of course, I do have to remind you how to seed your calculators because all of your calculators are automatically reset. We are going to generate 15 random numbers from 1 to 30. We are going to generate 15 random numbers from 1 to 30. I'm going to put a little note here. Repeats allowed because 13 out of 30 is a percent. More specifically, boom. I should write down, it's 43.3%. There was a note that I put into, when we put into your notes when we did random simulations back in the day, and it had to do with whether or not we were to include repeats. And one of the notes that I made was that repeats are allowed if you're dealing with percentages. And 13 out of 30 in this case is definitely a percentage. We're basically saying 43.3% of those people would improve no matter what. And now we're about to randomly simulate this junk. So I'm going to zoom in on my calculator. I'm just going to remind you of a couple things. Now we're going to seed our calculators. You're going to seed it using different numbers. Now, I would like you to seed it using your birthday. It's just the easiest thing in the world, just to say, hey guys, seed it with your birthday. I'm going to seed it with today's date. Now, what I'm going to do is today is 10/26/2020. You can do it whichever way you need to. Your birthday, if it's April, just do, 4. It doesn't matter. If I was born on April 1st, 4/1, and then whatever year you were born. Oh crap! You guys were all born after 2000. I just can't fathom that. You guys are weird. Anyway, there's a store button. I click that store button, STO. It is in the bottom left above the on button. I need to seed the calculator, so I need to store that into a random number. So I'm going to store that into the random number where I hit math. If you hit math, you come to this screen. I'm going to tab over to PRB, which is probability, PERB. And I'm going to click the first one, rand, to store it into that random number. If I do that correctly, ba-boom, done. I have seeded my calculator. Now again, your calculators automatically reset every time you close them and open them back up again. So as long as you don't close it, you're good now. As long as you don't close it, you're good now. So don't close it. Yeah. But you'll see every time you open it, it says like what, RAM cleared. Yeah. So again, you'll know if it's RAM cleared. If it's RAM cleared, you got to seed it with something else. So now I'm seeded. Now here's what I'm going to do. Watch what I am going to do, because I am going to run a simulation to determine whether or not dolphin therapy works. Now my thing, I'm only running one trial. We're going to have to run a bunch of trials. So I'm going to hit math. I'm going to go over to PRB, and I'm going to go to rand int. Rand int 1,30. Now, again, just as a reminder, because I zoomed in on the screen, I said, okay, we're assuming that 13 out of those 30, we're assuming 13 out of 30 are going to improve no matter what, regardless of dolphin therapy. I said I was going to let 1 to 13 be improve. I was going to let 14 to 30 be no improvement, not improve. And we're going to run this simulation, and we're going to determine a proportion. Oh no, my thing. There we go. Cool. So just watch what I'm going to do here. I'm going to have to generate 15 numbers. So 1, 2, 3, 4. Oh, actually, I got to keep track of this stuff. Okay, cool. Here, we'll do it this way. I need to borrow you. Sit over here. Yeah, quickly. Go. Now, all you're going to do is hit enter when I tell you to. Okay, so don't hit it just yet. Don't hit it just yet, because I need to keep track of this, and this is what you guys are going to do as well every time you hit enter. Keep in mind, you are only going to generate 15 numbers to complete the trial. You're going to generate 15 numbers to complete the trial. So this is going to be trial number 1, improve, no, or not, I should say. So hold on. 17 was not. 14 was not. 21 was not. 19 was not. All right, keep going. Oh, just hit enter once, and I'll tell you again. Okay, 14 was not. Go. 16 was not. Go. 18 was not. Go. 9, I got an improvement. Go. 4, I got an improvement. Go. 17, not. 11, not. Hold on for 1 second. 5, 6, 7, 8, 9, 10, 11. Okay, keep going. Oh, it was 11? Ah, you foiled me. So I'm thinking about too many things. Anyway, 14 was not. Keep going. 7 was an improve. Hold on. Keep going. Oh, you're good. Okay, 27 was not. One more. 9, good. All right, go. Now you notice when I stopped. I stopped the trial once I got to the 15th number. This was trial number 1. So trial 1. Then I don't need to reseed anything. but then I'm going to have to do trial 2. And this is going to be improve or not. Now, I'm not going to do it again with you guys, so don't worry about that. But to start trial 2, all I would have to do is, well, hit enter again, and I'd go from there. You don't have to reseed it. There's 26, and then I would go, not. And then I would keep going until I got to 15. Now, let me talk about a couple things before I set you off on this, because I'm going to have each of you do about like 5 trials, and I'm going to do 5 trials as well. And if you're joining in online, you could do 5 trials as well. But the 1 to 30 represent the 30 people who went down to dolphin therapy. The first 13 numbers right here representing the improvements, those are the people who we are assuming would improve no matter what, regardless of dolphin therapy. We're randomly generating numbers to see, okay, in my group of 15, would I get similar results to dolphin therapy? Well, here I got 5 improving. How many people improved for dolphin therapy? How many? No, I'm sorry, in the dolphin therapy information that I gave you at the beginning. 10 people improved. We generated 5. Interesting. So I'm going to have each of you do 5 trials. I'm going to ask for that single number, how many improved from the trial in a little bit. We're going to go down the list. So I'm going to do my 5 trials. I've already done 1. You guys complete your 5. Go! And I'm going to keep track of mine over here. There we go. Say it one more time. To seed it. Did you already seed it the first time? Okay. You only have to seed it once, okay? But you type in the number that you're going to seed it with. The STO button is on the bottom left. You see above on, okay? You hit that. Good. Hit math. Tab over to PRB. And the first option is the word rand, right? If you select that and hit enter, it says like the number again. You're seated. Yeah. Let me see here. T1. Improve, not improve. Okay. Let's try 1. Trial 2. Improve, not improve. Boom. Okay.
So weird.
Sometimes that happens. Sometimes that totally does happen. I did a trial where I just got 11 people improving. That's insane. Now, in the chat, just so you know, the only numbers that I need, and it's actually for all of you as well, I only need 5 numbers from you, 5 total numbers from you. I need the number of people who improved in that one trial. So you can see my 5 numbers right here. I had 5, 11, 7, 6, and 5. I was able to actually replicate dolphin therapy once, just once, because 10 was how dolphin therapy, how many they got. But I'm just going to need those 5 numbers from you. How many people improved in that particular trial? So, here we get numbers from. Say again? Yeah, 5 separate trials. I'll give you guys another a few minutes to wrap that up. And then we shall record some stuff. You guys ever see Beauty and the Beast? Okay, question. When all of the objects at the end of the movie turn human, did they have any silverware left over for the party? Right? So my question is, okay, here's my question now. Before they turned into inanimate objects, there were objects like that they used. They had like a spoon, for example. There was a spoon that existed before they got turned into them. And then afterward, either human beings got turned into a spoon or the spoon got the ability to move. Right? Isn't that weird? Like, think about this, you know? And now you have this kid who was a teacup who spent his entire life with people putting like their lips to his head. And all of a sudden he's a human being. And look how warped he is. At the end of the movie, he says, "Do I still have to sleep in the cupboard?" This kid's going to have a tough adulthood. Just saying. All of that to say the music is phenomenal. I do like Josh Gad and whoever that guy was in the live action one. Yeah, not the whole movie live action, but like just Josh Gad and Gaston in the live action. They were phenomenal. Okay. Anyone got some numbers for me? Yeah.
Well, I mean, how do you get there?
Oh, good. Okay, good question. Good question. Don't worry about entering in the numbers yourself. That's not the purpose of today. I'm just doing this because the purpose of today is to show you a graphical display on the screen. Okay? So don't worry about you typing in these numbers. Worry about me typing in these numbers. What do you got?
What do I tell you? Like, what improved and what improved?
Just improve. How many improved?
For first trial was 4.
Yep.
Second was
9.
9. Third was 7.
7.
Fourth was 8.
8.
And then fifth was 6.
6. Okay.
I'll do mine.
Sure.
So there's 7, 7, 5, 7, and then 9.
Oh, 1 second. Yeah.
I got 4.
Yep.
8.
Yep.
9.
Yep.
5.
Yep.
7.
Yep. Yeah.
I got 8,
8,
5, 7,
7,
3,
3,
5.
5. Oh, duh. What am I? That was that was 5. What am I even talking about? Now, I'm just double checking real quick. I'm checking the chat. Okay, because there's someone in there. I don't know if they were gonna do it with us. If you do it with us, I can add your numbers to it. But regardless, we got 25 results here now. These are very typical results. These are very typical results. These are all random, completely random. You seeded the number into the calculator. You all got different results. This is true randomness. Now, again, I'm asking that big question. Does dolphin therapy work, or is it the result of random chance? Let's take a look at some of these numbers. Now, first of all, I'm going to look at a graph here of the histogram. I want you to see the histogram of this. I'm going to zoom 9 that sucker. Look at that. That's interesting. There's a little bit of a gap there. Now, mind you, I have no idea what these results are going to look like beforehand. I have a good idea as to what they're going to look like, but I have no idea what these results are actually going to look like until we get here. Come on, marker. Check this out. It's not perfect. It's not perfect, and it never is. But this thing does have something of this general shape. Yes, there's a little bit of a discrepancy here and a little bit of a discrepancy here, but this does have this general shape, this very smoothish type shape. Now, here's the fun thing. I know for a fact that if we were to continue conducting trials, if I had you guys conduct 10 trials, which we don't have time for, if I were to have you guys conduct 15 trials, 30 trials each, the shape of this graph would become more and more and more this smooth curve. It would become closer and closer and closer to this smooth curve. This is an amazing graphical display. This is a histogram, yes, but it's displaying characteristics of what we call the normal distribution. We call it the normal distribution. The normal distribution is an amazing graphical display in statistics. And there's a lot of different things that we can learn from this normal distribution that we will get into in the next several class periods. Last Friday, I assigned you that video to watch on the normal distribution. Okay, none of you watched it. All right. It is due, it's due Tuesday. That's right. It's due Tuesday to watch it, But I wanted you guys to kind of be like, oh, this is what he's going to be talking about, kind of. And this is kind of like my slow burn intro to the whole thing. The what? Yeah, the lady. Yeah. Because the thing is, you may not understand everything in that video. That's fine, because I'm going to be stretching this out over the course of several class periods, But I'm doing that for a reason, because this is not the easiest thing to understand, but it is so vitally important. Now, I'm going to deep dive a little bit more into our numbers. Let's take a look at something here. We did 25 trials. Hey, check this out. I don't know if you knew you could do this. You see what I just picked right there? See what I just did right there? Oop, there it is. Didn't do anything, eh? What did it do to all my numbers? Yeah, it sorted them. It sorted them ascendingly. So awesome. Anyway, the reason why I did that, because I have these 25 trials. How many out of the 25 trials did we match or better dolphin therapy? How many people who swam with the dolphins improved out of 15? 10. Only 10 did. According to the numbers that I gave you, the actual dolphin therapy experiment. 10 out of 15 improved. How many out of our trials did we see similar or better results? Just one time. We were only able to replicate it once. So hold on. I have something to say about that. Zooming out, zooming out, zooming out. I'm going to come back to my calculator in a little bit. No, I got paper over here. Here we go. So, out of 25 trials, we were able to match or better dolphin therapy. I can spell therapy today. Therapy. Once. 1 out of 25 is approximately 0.04 or 4%. Out of 25 trials, we were able to match or better dolphin therapy just once. Now, it appears, now again, I'm being very vague with my wording. It appears, there's evidence to suggest, blah, 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 fluffy language. It appears that dolphin therapy is not the result of random chance. Because to get similar results only occurs 4% of the time based on our simulation. Let me explain what that means. We were trying to replicate the results of dolphin therapy. Hey, could dolphin therapy just be the result of random chance, like flipping the coin? If it's supposed to be 13 out of 30, maybe by random chance, they were able to get 10 people improving out of 15. So we did it. We ran the simulation 25 times. We ran 25 trials. And out of our 25 trials, we were only able to replicate their results 4% of the time. 4% is a very low number. 4% is under what they call, this is very important, 4% is under what they call the threshold of acceptability. There is a certain threshold. There's a certain bar where if you are under that bar, if you get results that are under that bar, like 4%, then, oh man, you actually have evidence to show that this thing might actually work. Think about like when they do like a trial for pills, for example. I don't know. Let me do something a little bit more real life. Let's see if they do a trial for vaccines. I don't know. And they're trying to see, hey, okay, I'm going to make something up. Let's pretend you all have corona. Yay. Whatever. I know, right? And then I have the vaccine here. And we're like, all right, cool. Boom, 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 boom. You all get the vaccine. Let's see what happens. Okay? Do you improve? Do you not improve? Are you immune? Are you not immune? These are the things that we need to see. But if you all have corona and I give you the vaccine, I know that's not how it actually works. You're supposed to get the vaccine before you get corona. I know that's actually how it works, okay? I'm not dumb. But if that were the case, actually, so let's switch it up then. If you get the vaccine and then they say, do you get corona? I don't know. But whether you improve or not, is it the result of random chance? Or is it the result of the vaccine actually doing its job? And so we need to see, if we simulated this, is it actually the result of random chance? Let me go back to my graph real quick. Let me go back to that normal distribution, because that's actually a really good thing right there. Chappelle. Zooming in, zooming in, zooming in, zooming in, zooming in, zooming in. Here we go. Graph. There it is. Chappelle. The normal distribution is something that they use in a lot of statistical analysis, especially when it comes to the medical field. Boom. This thing is supposed to extend forever that way and forever that way. There we go. So it's like that. But this shaded in region represents 4%, just 4% of that graph. If you were to shade in the entire thing, that would be 100% of the graph. But the results where we were trying to better or duplicate the results of dolphin therapy, we only got 4% of the time. Those chances are so small. Those chances are so small. It comes down to the following statement. Assuming that dolphin therapy doesn't work, assuming that 13 out of 30 of those people would improve no matter what, we were only able to replicate dolphin therapy 4% of the time. Dolphin therapy does not appear to be the result of random chance. Instead, this is evidence to show dolphin therapy works. Again, evidence to show. Am I saying dolphin therapy works? No, I'm not saying it works. I am not saying that it works. I am simply saying that now we have some evidence to show that it works. Where would you go from here? If you were a statistician and you did all of this, you're like, okay, I ran the 30 people with dolphin therapy. I ran the random simulation with the results. I got 4%. It seems there's evidence to suggest that dolphin therapy works. What would you do as a statistician? Would you go on the TV talk shows and cash in and say, hey, go swim with dolphins, read my book and pay me money? What should a responsible statistician do? I'm just asking you guys. I would. Do it again. Get 30 different people. See if you can replicate. See if you can replicate those results with actual people. There's no harm with swimming dolphins except they're killing machines. Have dolphins kill people? Let's Google it. I have no idea whether or not dolphins have actually killed people. I'm just going to assume that they're terrible things, you know. Sharks, of course, I know, but sharks are just, hungry. What do dolphins do? Hold on. Have dolphins killed people? Ooh.
That's clearly
It's from the New York Times.
No, but let's read. Maybe they're mistaken.
Everybody loves dolphins. No, just whatever. Oh, look at that from BBC. Cute and cuddly dolphins are secretly murderers.
Murderers of food.
Oh, look, they're jumping. Anyway,
Exactly. It doesn't say if it kills humans.
that's true. That's very true.
Yeah, like obviously they're playing.
Oh my gosh, it's so funny. That's so funny.
Like sharks, like one of those seals.
I know. So, couple of concluding statements before I talk about the normal distribution a little bit more. A couple of concluding statements. We can only conclude using phrases like it appears or evidence to suggest. We cannot make definitive claims. Definitive claims. The best course of action is to replicate dolphin therapy with real people. Now, I'm not asking you guys to do that because that's going to cost obviously a lot of money. But again, it doesn't make that much noise, The people who actually do run this dolphin therapy are probably people who work for various corporations, pharmaceutical companies, things of that nature. Perhaps if I was working for a pharmaceutical company, I would put in the recommendation, hey, let's do dolphin therapy again, but let's have two more groups of people. We'll have two more groups of people, one who swim with dolphins and take our pill that could help with depression, and the group of people who don't swim with dolphins and take our pill that helps people from suffering from depression. If I was a statistician, I would do something like that. I would make that recommendation, and then I would go about organizing this experiment. People get paid for this kind of stuff. People get paid to set up and execute experiments like this. They get paid good money. Like, think about it. Like, I'm going to take 30 people down to, what's a Caribbean island? Jamaica, whatever. I don't know if there's dolphins down there. But you go down to Jamaica, and you basically get these people to adhere to the rules of your experiment. And you're in Jamaica conducting an experiment with dolphins. I don't know. That's kind of cool. Whatever. Let's talk about the normal distribution a little bit. Because again, this whole chapter, this whole unit that we've been covering has been on graphical displays. So I want you to draw the following shape as best you can. This is what we call the normal distribution. A lot of real-life data, when graphed, show this bell-shaped curve. A lot of real-life data, when graphed, show this bell-shaped curve. Sometimes the bell-shaped curve is not obvious at the very beginning. Sometimes you have to run a bit more trials. But the more trials that you end up running, the more subjects that you end up collecting, the more data you get, the more bell-shaped that it looks. Now, let's just say, for example, I specified, hey, let me go out and collect data on the heights of a bunch of adult men. And I would specify men because, and adult, because men are typically taller than women on average. And I would say adult because by that point, the man has stopped growing vertically. I would assume. I don't know. So if I collected data on like a couple hundred adult men and their heights, and I put them into a graph, I guarantee you that the shape of that histogram would be this, or something very close to this. A normal distribution is symmetric. It is what we call unimodal. We call it unimodal. Now, I say unimodal, like you've heard the word mode before. But when I say unimodal, I mean it literally just has like one peak. It has one peak. And obviously has this kind of bell-shaped kind of curve to it. Have you guys ever heard of a paranormal curve? So this is a normal curve, okay? This is a paranormal curve. You walked right into that one. You know you did. This is statistics humor. Anyway.
I was about to ask if it was like, I don't know, like a ghost.
I know. But the normal curve is actually real, just so you know. So hold on, right down the center. Right down the center of this curve. X bar is right down the center of this curve. That's where your mean is. The mean of the distribution, the mean of the histogram would be right in the middle of that graphical display. Now, a little bit farther down right here, I'm going to add in some additional dots, if you notice where I'm adding those in to the right. I'm trying to keep them equidistant from each other along the bottom here. Equidistant. Such a grown-up word. This would be x bar plus s. Remind me, what is s again? Ooh, from last week. Not the sum. The s that you get from your calculator, the s that you would calculate would be your standard deviation. Your standard deviation. Standard deviation is a measure of spread. Standard deviation shows you how spread out your data is. Standard deviation is like average deviation from the mean. So if I were to take x bar and add one standard deviation to it, that's where I would be on the normal curve. This would be x bar plus 2s, and this would be x bar plus 3s. And in fact, again, the whole thing is symmetric. So going the other direction would be very similar, except you'd be subtracting it. This would be x bar minus s. This would be x bar minus 2s. And this would be x bar minus 3s. This is the proper setup for the normal distribution. Now there's one more thing that I have to add to this picture. Because again, as I said last Friday in that post about watching the video, I was slowly but surely going to start introducing the normal distribution. The whole purpose of dolphin therapy today was to review random simulation and to get that graphical display and to review writing conclusions, of course, but eventually it was to get to this. If you were to take some characteristic of human beings, I'll go back to height. IQ, let's go to IQ. IQ doesn't matter how tall or short you are, I hope, whatever. But if you look at adults in the United States and you look at IQ, do you know what the average IQ is? Do you know what IQ stands for? Intelligence quotient. Do you know how they calculate it? Okay. The intelligence quotient basically does this. How old are you versus what is your mental intelligence? So they give you a test and they measure what is known as your mental intelligence. They give you a certain score. Now, if I'm 36 and I score a 36, what's 36 divided by 36? Multiply it by 100. That's average IQ. Average IQ means that your mental intelligence matches your physical age. That's what IQ is. You said intelligence quotient. The quotient is dividing two numbers. So the average IQ is 100. And then basically it's like, okay, if the average IQ is 100, I don't know what the standard deviation is. Let's say the standard deviation is like 15 or some junk like that. I don't know. I'll say it's like 10, whatever. Keep it simple. Then if I were to go up one standard deviation to 110, and I were to go down one standard deviation to 90, I would capture approximately 68% of all people. If I were to take the average IQ and go up one standard deviation and down one standard deviation, I would capture 68% of all people within that range. Now, it's also 68% of the area under the graph, but I'm going to get into those details another time. If I were to go out 2 standard deviations away from the mean, I would capture 95% of all people. 95%. They say that if you are a data point that lies more than 2 standard deviations away from the mean, if you are a data point that is outside this 95% range, then you are considered unusual. You are considered unusual. If you have somebody with a slightly elevated IQ, like 150 or some junk like that, they're considered unusual. These are like the most intelligent people in the world. If you have somebody who has like a very low IQ, like 60 or 70, that is also considered unusual because it is not close to what we call the norm, the middle, the mean, things of that nature. Now, if you go out 3 standard deviations, you almost have everybody. You almost have everybody. You have 99.7% of people. It's actually something called the empirical rule. It's the empirical rule is also known as the 68, 95, 99.7 rule. So think about that, 99.7%. What is 99? How many Barnegat High School students are there? Like 1,000? Okay. If I were to say there were 1,000 Barnegat High School students, and I was trying to get 99.7 of them, that would be 997 people, which means out of all of Barnegat High School, only 3 people would fall outside that range. Very unusual. Very unusual. Think about Derek. Derek is probably all the way up here. Dude's super tall. He just is. Me, I would probably fall in this range right here. Like for an adult male, I'm short, but I'm not that short. I know some people who are adult males and who are shorter than me. Sucks to be them. They'd be down here. Derek be up here. How tall is like Shaquille O'Neal? Is he over 7 foot? Yeah, the dude would be like way up here. You know, some of the tallest people in the world be up here. See, the thing is, going out 3 standard deviations doesn't get everybody. Doesn't get everybody, but it gets most people. Anybody outside that range is considered, a heavy outlier. Oh, the normal distribution. We are going to be spending some time with this normal distribution. We're going to, again, slowly but surely introducing this thing and showing you how to do various calculations with it. It's going to be amazing. For me, not for you. It's just going to be amazing for me. Paranormal. What? Anyone being anything for Halloween? I'm not. A minion. Hold on 1 second. Hold on. Where are my kids? Yeah, that's a bad word. Here we go. I'll zoom in there. My kid got a Pikachu outfit. It's going to focus. Oh, I can't see it that well. But he got a Pikachu outfit where like the head is like a Pikachu, like that. Look, like that. But they're pajamas. She's a unicorn.
Is it a onesie? Like a onesie?
Yeah. It's like a giant onesie pajama thing. Anyway. But he's going to be a Pikachu. It's going to be amazing. Because my wife made him a mask that is a Pokeball. Amazing. All right, I'm going to sign off.
See you on Monday.
Wait, no, I won't see you guys.